Hi guys, welcome to another Easy Maths video. Now, in preparation for the GCSE non-calculator exam on Tuesday, I wanted to go through some of the hardest questions on the higher paper. So I've got three types of questions, they're all from different topics, and you're most likely going to see these questions right at the end of the exam. They would most likely be the last question. So the first one is to do with probability. So it says, Mr. Lucky plays two games. The two games are Game A and Game B. Playing Game A and playing Game B are independent events. The probability that Mr. Lucky wins both games is 9/25. The probability that Mr. Lucky wins Game B is 4 times greater than the probability of him losing Game A. Find the probability that Mr. Lucky wins only one of the two games he plays. You must show full workings. Right, so the first thing I'm going to do is draw a tree diagram. So we've got our two independent events. So the first one is Game A. And then if I draw the branches for the second independent event, and then I'm just going to move this down slightly, and this is Game B. So if we say this branch is a probability of winning, this branch is a probability of losing. So we don't actually know what these probabilities are. So let's introduce two variables. A variable for the probability of winning Game A and another variable for the probability of winning Game B. So let's say that the probability of winning Game A is represented by the variable X, and the probability of winning Game B is represented by the variable Y. So that means the probability of losing Game A would be 1 minus X, because those probabilities add up to 1. And then the probability of losing Game B would be 1 minus Y. Probability of winning Game B would be Y, and probability of losing would be 1 minus Y. So we're told in the question that the probability that Mr. Lucky wins both games is 9/25. So that is saying X times Y equals 9/25. So that's the first thing we can write down. Now, the next part of the question said that the probability that Mr. Lucky wins Game B is 4 times greater than the probability of him losing Game A. So the probability that he wins Game B is represented by the variable Y. And that's equal to 4 times the probability of him losing Game A. Or the probability of him losing Game A is 1 minus X. So we can simplify this. We can say Y equals 4 minus 4X. So what we can do now is we can replace Y with 4 minus 4X. So we can say X multiplied by 4 minus 4X is equal to 9/25. Okay, so if we expand the left-hand side, we're going to get 4X minus 4X squared equals 9/25. And what I'm going to do is I'm going to multiply through by 25. So we're going to get 100x minus 100x squared equals 9. So what I'm going to do is I'm going to bring the x squared term and the x term over to the right hand side. So I'm going to get 100x squared minus 100x plus 9 equals 0. Now, when we factorise this, we're going to get two factors, which are going to include 10x, because 10x times 10x is 100x squared. And then the two factors of 9 we can use is 9 and 1. So this would be 10x minus 1 and 10x minus 9. So when we expand that, we get 100x squared minus 90x minus 10x, which is minus 100x. And then minus 1 times minus 9 is positive 9. So that works. We can make that equal to 0. And then when we solve this, we get x equals 1/10 or x equals 9/10. Now, using these values for x, we can work out our corresponding values for y. So if we use the formula y equals 4 minus 4x, which is the same as y equals 4 all multiplied by 1 minus x. I think that's going to make it a little bit easier. Well, if we use when x is 1/10, well, that's going to be y equals 4 multiplied by 1 minus 1/10, which is 9/10. And that is 36/10, which equals 3.6. Well, y, we said, is the probability of winning game B. Now, we know that probabilities cannot be greater than 1, so this is an invalid solution. So we can say, therefore, 3.6 is an invalid solution, as y cannot be greater than 1. Let's try our other value for x, which is 9/10. So that would be y equals 4 multiplied by 1 minus 9/10, which is 4 multiplied by 1/10. And that gives us 4/10, which is the same as 0.4. Now 0.4 is smaller than 1. So that must be our probability, the probability of winning game B. So that means we've got x equals 9/10 and y equals 4/10. Now, because we've got values for x and y now, we can now work out the question. And remember, the question said, find the probability that Mr. Lucky wins only one of the 2 games he plays. So if he wins only one of the 2 games he plays, that means he could win game A and lose game B, or he could win game B and lose game A. So if he won game A and lost game B, the probability of winning game A is 9/10, and the probability of losing game B is 1 minus 4/10, which is 6/10. So if we multiply those together, we get 54 over 100. Now we've got all the probability of winning game B and losing game A. So the probability of winning game B is 4/10, and the probability of losing game A is 1 minus 9/10, which is 1/10. So that simplifies to 4 over 100. Now, because we've got this first condition or this second condition, we can add the probabilities together. So we can say 54 over 100 add 4 over 100, which is 58 over 100, which simplifies down to 29 over 50. Question 2 is to do with similar shapes. It says triangle ACD is shown in the diagram below. AED is a straight line. AB has a length of 3 root 5. AE is equal to twice the length of BE. And 3 times the length of AD is equal to 5 times the length of AE. Find the area of the shaded quadrilateral BCDE. Okay, so let's label this diagram. So we know AB is 3 root 5. We know AE is equal to twice the length of BE. So let's say the length BE is denoted by x. So that means AE we can represent as 2x. Now AD, which is the base of this triangle here, and I'm going to call this y, 3 times this length is equal to 5 times the length of AE. So we can say 3 times y, which is 3y, is equal to 5 times the length of AE. Well, I said AE is 2x because it's twice the length of BE. So we can say 5 multiplied by 2x. We can simplify this to say 3y equals 10x. So now what I can do is I can rearrange this to show that y is 10/3 of x. And that gives me the base of the triangle, gives me the length of AED. Now, because I said this question is to do with similar shapes, and we can see that these two lines here are parallel, and they're both made up of right-angled triangles, we must have two similar triangles. So the two triangles are made up of the same angles, but the length of their sides are different. So that means there's going to be some sort of scale factor which we've applied to the triangle ABE to then enlarge it to give us the triangle ACD. So we can work out what that scale factor is because we know y, which is the length AD, is 10/3 of x. And we know that the length AE, which is the base of the smaller triangle, ABE, is 2x. So what have we multiplied 2x by to get 10/3 of x? Well, that's easy, that's 5/3. So our scale factor is 5/3. So what we can do is we can apply that scale factor to the length BE to work out the side length of CD. Well, that's easy because that's just going to be 5/3 of x. Now, when we're trying to work out the area of this quadrilateral, you should be able to see that this quadrilateral is a trapezium because we've got two parallel lines which are of different lengths, and then we've got this perpendicular height which represents the base of the trapezium. Now we can work out that length ED by doing y minus 2x. Well, y is 10/3 of x, so we can say ED equals 10/3 of x minus 2x. Now, to make this a bit easier, I can say that 2x is the same as 6/3 of x, so we've got a common denominator of 3, and then we can simplify this and we get 4/3 of x. So if I label this as 4/3 of x, we can use the formula for the area of the trapezium to work out what the area of what BCDE is. So we know that the area of a trapezium is equal to a half A plus B multiplied by the height. Well, in this case, we're going to have a half of the shortest length, which is x, plus the longer length, which is 5/3 of x, multiplied by the height, which is 4/3 of x. Now, if we simplify what's inside this bracket, we're going to get a half multiplied by x plus 5/3 of x, where we can make x the same as 3x over 3. So that's going to simplify to 8/3 of x, and then multiplied by 4/3 of x. So now, if I multiply all of these quantities together, I'm going to get 32 over 18 x squared. So that is my expression for the area of the trapezium. Now, the question doesn't say find an expression. We actually want to work out what the area of this trapezium is. So what we can do is we can look at this smaller triangle, ABE, and because we know that the length of AB is equal to 3√5, we could use Pythagoras' theorem to get a value for x squared. And then we could substitute that value of x squared into our expression for the area of the trapezium. So if we use Pythagoras' theorem on the triangle ABE, we're going to say that 2x all squared plus x squared is equal to 3√5 all squared. Well, 2x all squared is the same as saying 4x squared, and we've got plus x squared is equal to 3√5 all squared. Well, 3√5 all squared, that's 3 times 3, which is 9, and then 9 times √5 all squared is 5, so we're going to have 9 times 5, which is 45. And then we can simplify the left-hand side, we're going to get 5x squared equals 45. Divide both sides by 5, we're going to get x squared equals 9. So now I've got a value for x squared, which I can then substitute into the expression 32 over 18 x squared. So the area of BCDE will equal 32/18 multiplied by 9. Well, 9 over 18 is a half, and a half of 32 is 16 units squared. And that is our final answer. Question 3. This was a question that was actually taken from the June 2017 exam, and it was the last question on it, and it's probably one of the most difficult GCSE questions I've seen on the non-calculator paper. So it is quite tricky, this one, but we'll go through it step by step. So it says the diagram shows a hexagon ABCDEF. ABEF and CBED are congruent parallelograms where AB equals BC, which equals X. So both of these sides equal X. P is a point on AF and Q is a point on CD such that BP equals BQ, which equals 10. So we've got two lines which connect B to P and B to Q, and these are 10 centimeters in length. We're told that angle ABC is 30, so that's this whole angle here, so that's 30 degrees. And then we need to prove that cos PBQ, which is this angle in here, just between the two 10 centimeter lines, we need to prove that it's equal to 1 minus 2 root 3 all over 200 multiplied by x squared. So the key to this question is we need to look at two different triangles. I'm going to draw these triangles out. The first triangle is going to be BAC. And that's A and that's C. Now we know that the angle ABC is 30 degrees. The length of AB is X and the length of BC is X. Now, and I'm also going to draw the second triangle which we're interested in, which is BPQ. And I'm going to draw that next to it. So BPQ. I'm trying to find this angle, which I'm going to call PBQ. We know that the length of PB is 10, the length of BQ is 10, and that's all the information we're given. Now, what we can do here is we've got two different triangles. They're non-right angle triangles. We've got two side lengths, and we've got one angle. So we could use the cosine rule to work out the other side length. So we could work out the length of AC, and we could work out the length of PQ. Now, something that's interesting about the lengths of AC and PQ is if we look on the diagram, you should be able to see that AC is the exact same length as PQ. So what we can say is we can make AC, we could call the side length of AC A, and we could call the side length of PQ A as well. So now, using the cosine rule, we can try and work out an expression for A. So it's going to be A squared equals x squared plus x squared minus 2 multiplied by x multiplied by x multiplied by cos 30. Now, if we simplify this, we're going to get a squared equals 2x squared minus 2x squared cos 30. Now, we do have to know what cos 30 is without using a calculator, so we can use one of our trig triangles. So we can say that this is a side length of 1, this is a side length of 2, so that must have a side length of root 3. That's an angle 60, that is an angle 30. And cos 30 is adjacent over hypotenuse, so it's equal to root 3 over 2. So we can say that a squared is equal to 2x squared. Now minus 2 multiplied by root 3 over 2, the 2's are going to cancel, so we're just going to have minus root 3 x squared. Now, and I'm not going to square root both sides to just get a value of a, we'll just leave it as a squared at the moment. So if we try and work out another expression for the triangle PBQ, we can use the cosine rule again, so we can say a squared is equal to 10 squared plus 10 squared minus 2 times 10 times 10 multiplied by cos PBQ. Now that's a squared equals 100 plus 100, which is 200, minus 2 times 10 times 10, which is 200, cos PBQ. Now we've got another expression for a squared. So what we can do is we can make these two expressions, this one here and this one here, we can make them equal to each other. So we can say that 2x squared minus root 3x squared equals 200 minus 200 cos PBQ. Now, if we look at what we're trying to prove that cos PBQ equals that result up there. So we need to make cos PBQ our subject. So what I'm going to do is I'm going to subtract 200 from both sides. So we get 2x squared minus root 3x squared minus 200. And that's equal to minus 200. Just move this over a bit. Cos PBQ. Now we can divide both sides by minus 200. So that's going to leave us with 2x squared minus root 3x squared all over minus 200. Now minus 200 over minus 200 is going to be plus 1, and that's equal to cos PBQ. All we need to do is move the negative in front of minus 200 to the front of the whole fraction and then factorise out x squared. So we can say that we've got cos PBQ equals 1, subtract 2 minus root 3 all over 200, and then of course we can factorise that out. Factorise out the x squared. And that is the result that we got, which we were trying to prove. Thanks for watching the video, guys. Don't forget to subscribe to the channel if you haven't done so already. Make sure to also check out our website at www.easymaths.com